Hello there, Mr. Sutton here, bringing you this lesson on the quadratic formula. In this one, we'll be solving equations first by square rooting, and then, when that fails, by using the quadratic formula. For our real-life application, we're going to see how long it takes for a projectile to fall to the ground. For the warm-up, we are being asked to solve this quadratic without factoring. So the key situation here is a quadratic equation that doesn't have a linear term. Notice there's no x to the first power anywhere in here, unlike the ones we've done before. These can actually be solved by isolating and square rooting the quadratic term. So in other words, basically just getting x squared by itself on one side, some number on the other side, and taking the square root. So with that in mind, see if you can go ahead and solve this equation by square rooting. All right, if I want to get x squared by itself, I need to subtract 3x squared over to the left side, giving me 8x squared. And then I divide both sides by 8 to get x squared truly by itself, so that's 20 on the other side. And at this point, since I've got x squared by itself, I'm ready to square root both sides. Now, when I do this, I actually have to write a plus or minus right next to that radical 20. We need a plus or minus when square rooting equations. It's not built into the square root, but when you're square rooting an equation, you're asking what could I plug into x squared to get 20? Well, whatever the square root of 20 is, that would give me 20 if I plugged it into x squared, but also the negative square root of 20. If I squared it, because a negative times a negative is a positive, that would also give me 20. So we need a plus or minus in this situation. And now, just simplifying things, we have just x on the left side, and on the right side we can split this radical up a bit and put it in simplest radical form. So this can be rewritten as 4 times 5 inside a square root, which gives us plus or minus 2 radical 5. Here's another example for us to try out. So the process of solving by square rooting can actually be used in this situation as well, where you have x inside a squared parentheses. Pause the video and see if you can use square rooting to get to the bottom of this one. All right, now just like before, we need to isolate the squared thing. In this case, we need to subtract 6 and then divide by 9, so that's a negative 5/9 on the right side. And now that we have the squared thing by itself, we can square root both sides. So that'll give us just x minus 1/3 on the left side. And on the right side, there's a whole bunch of things going on. We have to use the plus or minus because we square rooted an equation. We have a negative inside the square root, so that's going to give us an I. And then we have radical 5 over the square root of 9, which we can call 3. So when the dust settles, that's plus or minus I radical 5 over 3. And we're almost done. Just one more thing. We have to actually get x by itself by adding 1/3 to the other side. Since we have two fractions, both with a denominator of 3, we can actually combine that so that we have 1 plus or minus I radical 5 all over that common denominator of 3. Now that we've seen the technique of solving by square rooting, could we use it to solve something like this problem here? Well, could we write something like, and I'm just solving for x now, if I wanted to get x by itself, could I do something like, I don't know, 8x minus this 1, divide by the 11 to get x squared by itself, and then plus or minus square root both sides? Actually, no, we cannot do this. The biggest problem, if you look closely, is that we have an x inside our solution. You can't say x equals something with an x. It just doesn't make any sense. So in order to do these problems, where you have this linear term here that's messing things up, we have to use something called the quadratic formula. So here's the quadratic formula, and I'm about to show it to you. There's a big proof of it that you can look up on your own, but this lesson's already long enough without that. So if you have something in ax squared plus bx plus c equals 0 form, so decreasing order of exponents, 0 on one side, just like when you were solving by factoring, then we can write the following. X is going to equal, and now we're going to do something with a, b, and c to make this work. We're going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula, and we're going to take it for a test drive. Let's do it. All right, so here's that problem again that gave us some trouble, but now we've got some extra things we can use on it. So the general situation here is we have a quadratic that has a linear term, and we don't feel like trying to factor it. In this situation, we're going to use quadratic formula, which means you need to know A, B, and C. But before you can figure out A, B, and C, we need to put this in standard form to find those. So let's take a moment to do that. Pause the video and see if you can get this back into standard form. All right, so we want decreasing order of exponents with everything on one side. So if we just subtract this 8x over to the left side and put it between the 11x squared and the 1, we will now have something in standard form. And once it's in this form, we can just go from left to right and pick out A, B, and C. So we have A, the coefficient of x squared, which is 11. B is this negative 8. The negative comes with it. And then C is just the constant there. That's 1. And at this point, we're just going to plug it in the quadratic formula. Now, every time I use this, I always rewrite it. Negative b plus or minus square root of b squared minus 4ac all over 2a. If you say it enough times, you might actually remember it. So there's a lot of things going on. I don't want to lose anything by trying to plug things in blind here. So I always am looking at this when I plug things in. And now plugging everything into this formula, we've got our negative b value here, negative 8. And then we have a negative 8 being squared in there because b gets used again. Minus 4 times our a value we said was 11. And then we have a c value of 1. All over 2 times the a value gets used again. We have 11 down there. And at this point, we're just going to simplify this as far as we can. So we've got negative 8. That's going to be positive 8. Inside, just take it in steps. We have negative 8 squared. That's going to be 64. And notice I had this negative in a parenthesis so I don't lose anything. And then we have 4 times 11 times 1, so we're subtracting 44. All of that over 2 times 11, which is 22. And then 64 minus 44, we can just make that 20. So at this point, we're pretty simplified, but we're not quite there. It looks like this radical can be simplified a little bit, and also we might be able to reduce this whole fraction. So if you have both of those things to do, you should always simplify the radical first before reducing. Because the 8 and the 22, you can only reduce those with whatever the coefficient outside this radical is. You can't touch anything inside. So what could I split 20 up into? Oh, well, we actually did this earlier in the lesson. That's 4 times 5. And that means we have really 2 radical 5 right there. And now let me look at my numbers. 8, 2, and 22. Those could all be reduced by 2. So if I do that, 8 is going to become 4, 2 is going to become 1, 22 becomes 11, and then finally I've got 4 plus or minus just radical 5, I guess, all over 11. Given all the work that we use to solve quadratic equations, I think it's time for a real life or death problem based off of these. So quadratics are great for when you have situations with things going up and coming back down. For example, let's say we have an army on a hill firing some arrows at a bunch of rebels on a place that's 120 feet below, so loose. Oh no! And we want to figure out basically how long it's going to take these arrows to reach that other army. And it might be nice to calculate this before you get on the battlefield. So let's say we have an arrow's height given by this h equals vt minus 16t squared formula, real formula. And v is just the speed of the arrows, h is the height, t is the time they've been in the air. Based off of that, how long does it take those arrows to get back down there? So just plugging in a few things, and this is just kind of the inspiration for our real-life problem. We're solving for t because we're asking how long, and that means for h we need to plug something in. We want the arrows to be at a height of 120 feet below, so that's negative 120. V is our arrow speed, which they set up here was 56 feet per second. And then this minus 16t squared, we don't know t, so that's going to stay the way it is. So let's go ahead and solve this now. So this is our classic quadratic formula situation. We have a linear term, and we really don't feel like factoring this thing. So let's again start by getting this in standard form. Take a moment to do that. All right, so it's up to you which way you move things. I'm going to move everything over to the left just so I have a positive squared term. So that would give me a positive 16t squared, and then I'll subtract 56t, and I'll still keep this negative 120 over there. And all that equals 0. Now, before we go ahead and use the quadratic formula, you can actually make your life a little bit easier if all your terms are divisible by the same number. You can divide by a constant GCF before using your formula. So what would be a number that these are all divisible by? Well, I think 8 will work, but let's try it out. So if I divide everything by 8, 16 is going to become a 2, so that's 2t squared, minus, this is going to be 7t, and then 120 divided by 8 is 15. So this is a little bit nicer numbers to plug into our quadratic formula. Pause the video and now finish this out using that lovely formula. All right, so here's that formula again. Plugging things in, we're going to have negative 7 for our b value out there, plus or minus square root of negative 7 squared, minus 4 times the a value 2 times the c value negative 15, all over 2 times our a value of 2. Simplifying a little bit further, this is going to be a 7 out there, plus or minus we have square root of 49, minus, well, let's see here, 2 times negative 15 would be negative 30, negative 4 times negative 30, that's 120 that we're adding now, because we had 2 negatives, and all that over 4. 49 plus 120, that's 169. And you can use your calculator to check this, but this is actually 13 if you square root 169. So this is the first time we've not had a radical up there. If you have this lovely situation where you can actually combine the numbers in the numerator, you do actually have to do that. So this actually ends up giving us 2 different solutions. I mean, we always had 2, but now we can actually tell a little bit more about them. We have 7 plus 13 over 4, and we also have 7 minus 13 over 4. But first, let's take care of this solution. So this is going to be 20 over 4, which is 5. And now we said 7 minus 13 over 4. That's going to be negative 6 over 4, which I can reduce to negative 3/2. So these are the 2 algebraic solutions. But if this was a real-life problem asking how long it takes arrows to come back down, probably we want to take the positive number. Negative time just doesn't really make sense. So 5 seconds would be our real-life answer, but these are both algebraic solutions. For our wrap-up on this one, quick, pause the video and write out the quadratic formula. All right, so here it is again. You do need to memorize this and pay attention to the details. Don't forget that plus or minus. A lot of people forget that in there. Look on the bright side, though. It could be worse. So there is a cubic formula out there for solving cubic equations. It has 3 different solutions. Here's the formula for solution number 1. Here's solution number 2. And here's solution number 3. So yeah, it could be a lot worse. Now, something that is kind of interesting about this, if you look at the very end of solutions 2 and 3, oh, what's that letter? That's I. Now, that's kind of interesting. Okay, so anyway, that's all the time for this one. Till next time, Mr. Sutton signing off.